Well, hello again. I'm Michael Murray, a program manager on the Longhorn SDK team, and this is Jeffrey Van Gogh, who's a developer on the Visual Studio Enterprise team. And this is the lunchtime in-depth bonus session on introducing FxCop, where we're going to show you how to use the FxCop tool in great detail and give you a bunch of demos and give you some things that you can try yourselves hands-on. So let's start, as you'd imagine, with the definition. So what is FxCop, for those of you who are not familiar with the tool? FxCop is a free-for-download, standalone code analysis tool that examines managed assemblies for design and code correctness issues, which is a very fancy way of saying it's something that validates the design guidelines. We provide a console and a graphical application in order to analyze targets. Targets are managed assemblies. Rule sets, which are the things we apply to your managed assemblies to enforce guideline patterns. And messages, which is the product of applying those rules to your targets. So let me talk just very quickly, before we jump into a demo, about the goals for FxCop. The primary goal for the FxCop tool is to support adoption of the .NET design guidelines, which are things that Brad and others have talked about as part of this session. So when I was first learning about the .NET frameworks, I tried reading through the design guidelines, and I think I got up to about page 50 or something like that before I fell asleep. And then what I found to be a much more tractable way of understanding the best practices in .NET was to write an application, use the FxCop tool, let the FxCop tool tell me where I was doing something that was in violation of the design guidelines, and then go and read the appropriate design guideline to understand the pattern and to really understand deeply what I was doing in my code and why it was the right way to do it. So I think the tool adjunct to the design guidelines is probably the best description of what FxCop really is. Another important goal for FxCop is that it transfers expert knowledge regarding technical issues and potential gotchas from the framework and from .NET. So, for example, one of the perf architects on the CLR team, or Rico or somebody like that, will point out or find a design pattern that people are using in code where they should be using a different design pattern. Very often, the perf architects will suggest a design guideline that shows people how to avoid the pattern that might be a problem, and we'll create an FxCop rule to codify that guideline so that it runs against your code without you having to police it yourself. So it's about as close as we have right now to being able to ship an expert in the box with every version of the CLR. It also establishes best practices that minimize code defects and maintenance costs. So there are patterns, there are kind of anti-patterns, things you should avoid when you're using the .NET platform, and for a lot of people it's a new platform and a new framework. And there are FxCop rules that will point out to you where you're using these patterns and things you should watch out for. Also, this is something you'd have to do yourself otherwise, so it's very useful that way as well. So without any further discussion, we're going to jump right into a demo here. Let me switch over the video. There we go. And Jeffrey's going to quickly walk you through the tool and illustrate what I was just talking about. So now let's drill down a bit, I think, on what FxCop rules can do. FxCop rules can analyze all managed metadata, so all information that's expressed in your assemblies. We can create rules to check for conditions on those things. That includes, attributes in your assembly, anything on types, on methods, on parameters. We can also do things like examine IL method bodies in order to look for certain patterns. For instance, some of the performance rules that we're going to illustrate for you today do exactly that. We can walk assembly call graphs, for instance, to look at the call tree for enforcing certain types of rules. And we can also do things like determine some argument values for call sites. So we have rules based on how you're using exceptions, for instance, that will look at what you're providing as argument values. We can even do things like use a spelling checker if Microsoft Office is installed. So anytime you get an FxCop violation related to a name that you use in a public type, if it's not a word or an acronym or an abbreviation that's already known in the dictionary, we'll use Office's dictionary to determine that. although many people who are using FxCop in their organization have acronyms or industry terms that are not part of Word's dictionary. We have a way for you to extend that using a custom dictionary.xml file, so you can stop that FxCop violation from appearing, basically, if you have acronyms that make sense for whatever your problem domain is. So let me just talk very quickly about the types of FxCop rules that come with a product when you install it. We are going to talk about how to write custom FxCop rules as well, so you can write your own FxCop rules. And I'll show you some examples of how to do that. But here are the kind of categories of rules that are in the product by default. And Jeffrey's going to walk through this in a minute and show you in detail examples of each one. But here are the definitions. So COM interop rules is the kind of thing that Sonia was talking about in the first session this morning. That looks for COM interop issues in terms of how you're using COM and how you're interoping with COM. And we'll show you some examples there. Design rules look for potential design flaws. Those are related to a lot of the things that Brad was talking about yesterday, for example. Globalization rules detect missing or incorrect usage of anything you normally provide as a parameter for globalization and localization. So if you're not specifying a culture info, for instance, someplace where you're expressing a message to a user, you'll get a violation about that. Here are there rules that govern that. Naming rules are the things that we spend amazing amounts of time discussing here at Microsoft about things like whether to use Pascal casing or not in certain cases, how to avoid keyword collisions when you name your types, and other issues around public members. It's interesting here in that, given that this is probably the most straightforward category of rules, I wouldn't be surprised at all if it takes up the most time in terms of debate. Just because how you name things in terms of public members seems to be a very religious issue for many of us. But performance rules, like I mentioned earlier, will detect patterns that affect or degrade performance, and we've got some examples that'll show how to favor using string builder versus concatenating strings, for example, in loops that have depth, having a performance implication. Usage rules looks for flaws in the way you use the framework of the .NET APIs. So for example, how you use collections and things like that. We've got some rules that will tell you when you're doing something that will impact your application. And then security rules look for programming elements that leave your assemblies vulnerable to malicious users or code. This last comment is actually wrong. This is from a Microsoft security presentation we did. We're not going to spend the rest of our time talking about security rules, but Sebastian will spend 2 hours talking about it this afternoon. And then custom rules, as I mentioned, is how you create your own FxCop rules and you plug them into the tool, and we're going to show you how to do that as well. So Jeffrey now is going to explain in detail a couple of examples for each one of these kind of buckets of rules and categories.
Yeah. So I'll go over, I have a slide for each category of rules, and I marked the lines of code where there is an issue that FxCop detects with an arrow. These are all bad code cases, and I'll explain how to fix each one of them. So the first arrow on this page, we have a class that is visible to COM, but there is no public constructor on the type. So because COM doesn't know about constructors, nobody would be able to create an instance of this class in COM. Then you see on the same class, you see a static method. Static methods are also not visible from COM, and especially if you're using a factory pattern, you have to be aware that people using a factory pattern, using COM cannot see your factory pattern and won't be able to get instances of your types. So the way to fix those two violations is to remove the factory pattern and just make the class creatable with a public constructor that doesn't take any arguments. Then the .NET framework will automatically call this constructor if COM requests an instance of your class. The last one on this page, there's a struct here. The struct contains a private field, and you could potentially put something dangerous inside that field. And because you mark it private, you might think that you're protected. But structs, their private methods are visible from COM. So if you have a struct that's COM visible, make sure that your private fields contain no sensitive data. So let's go to the design rules. I showed two issues here. The first one is on the property. This is what we often see in code when they want to specify passwords or some other security-related information. People only provide a setter to their property. Although this is valid IL, people don't. A lot of people think of properties as special fields. So they expect to be able to write to a field as well as read information from the field. And if you only provide a setter, that confuses a lot of people. So the right way to do this is to provide a method to set the passwords or other security sensitive data, and don't provide a property at all. The second sample on this page, we have a method that takes a file stream as a parameter, but it turns out that in this method, the only information from the file stream class is used. We only pass it to streamWriter, which takes a stream, and if you change this to the parameter to just be a stream instead of a file stream, you'll make your code more usable in later. Like, for instance, later you decide to be able to write this information directly to the network or to a COM port. If this was a public method and you made it a file stream, it would be a breaking change to change it. And if you just use the base class, if you only need the base class, you'll be safe for later on if you extend the usage. So some globalization rules. So the globalization rules are actually, you can divide them in two buckets. One that really find localization issues, and one that find issues if your user is running a different regional setting than you're expecting. So the first issue on this page, somebody throws an argument exception, but he has a hard-coded string in his code that tells the error message. So FxCop tries to find these hard-coded strings to exceptions and other APIs that we know that always should be localized. And if there is not a call to the resource manager in there, but a hard-coded string, we fire this violation. And the second issue is a globalization issue around regions. Version is a double, and we just write it to the exception right away as a string. And this uses the culture that the user defined. So, for instance, on some European cultures, the separator between the floating points is a comma instead of a dot. And so you write whatever the current user has chosen to the screen without making explicit what you want to be happening. Like, do you always want to have a dot, or do you want what the user decides to do? Then the third issue on this page, somebody writes something to his configuration, and he hard codes the path to program files. On localized versions of Windows, this path is very often named in the language of the localization. So if you hard code program files, the directory might not exist. And the last error is kind of like the second error, but it's more critical. So the same thing, you write a double, and you let the framework decide based on the region what you want to write. So for instance, you write, your version is 1.30, but if you're on a European system, it will write out 1.30. But then if the user decides to change his setting on his machine, opens the config file again, because the comma is also used in digits, it will think that it's 130. And you get all these weird issues because your version number is just wrong. Okay, so let's go over to some naming rules. The naming rules are just the things are how you name it, but also if you extend a certain type, you also have to adhere to specific naming guidelines. So the first one, there's a guideline that says if you extend exception, you need to suffix your class exception as well. Clearly that's not done here, so you can easily fix it by adding exception to this, removing error and changing it to an exception. The second issue, there are two issues in this name. One is that it should be Pascal cased, so it should start with a capital N, and then you should have underscores in your name. So this class probably should be named capital N naming, capital D for demo, concatenated to each other. The last line has 3 issues, so same thing, member name should also be Pascal case, so it should start with a capital N. And then there is ID. There's been a lot of discussion inside Microsoft and also outside of Microsoft how ID should be spelled. There's a rule that says acronyms with 2 letters should be both uppercase, but the problem is that ID is not an acronym, it's just an abbreviation for identity. So if you follow the guidelines literally, it should be capital I, small letter D. But if you look at HTML, they use capital I, capital D. So there's been a lot of discussion inside Microsoft and outside Microsoft. When we asked a lot of customers outside Microsoft, and what we found is that they want consistency. So we looked over the whole framework and the whole Longhorn, and we just ran a tool that detected how often capital I, capital D was used and how often capital I, small letter D was used. And it turned out that capital I, small letter D was used the most. So there's now a design guideline special case. If you have ID, you always have to say capital I, small letter D. So FxCop also detects this. Then the last one, the parameter should be camel case, so it should be a small letter N. Let's go to some performance rules. So the performance rules don't work on the metadata, they really work on what's inside the method body. And some performance rules are like easy to change patterns, others are just more difficult. So I'll show you some in here. The first arrow points to an issue where we compare our string to the empty string, but by providing the 2 double quotes, you have a string creation each time you loop through the for loop. So each time you are inside the for loop, it creates another string, compares it, and then throws the string away. What people often do is use string.empty to avoid the string creation, but then you still do a string comparison. So the fastest way to check if you have an empty string is to check the length of the string. So the code should say here, if output.length equals 0, then execute this code. Further, you see in this for loop that we concatenate the output to a lot of strings. So each time you concatenate this comma to the output variable, you'll create a new string because strings are immutable. So each time this method is called, you allocate memory. So a better way to write this code is to use a string builder. And in the last one where we do output, inside the for loop, the last one is also the same issue that we concatenate strings in a loop. So the best way to do this is to use a string builder, add everything to the string builder, and then call string builder to toString. The last item, so you see that we have some commented out code here. We previously used a private helper code that only this method called. Turned out we didn't need that method anymore, so we just commented it out, but we left the helper code in there. If you don't use the code and it's still in there, the C# compiler or any other compiler will still compile it. It will be in your binary. It will make your binary bigger, which makes your download bigger, makes your working set in memory bigger. And also it's less maintainable. If somebody goes back in your code a half a year later and sees this helper method, goes to figure out what it does, and then after that he figures out that the helper code is not used anymore. So FxCop detects private methods and internal methods that are not used anywhere and just warns you to just remove them. So let's go to some security rules. I've listed 3 security issues here. So the first one, we have a read-only public field that's an array. The problem here is that read-only only says that the pointer to the array is read-only. So it means you cannot swap out this array for another array. You cannot change the size of the array, but you can still change the data inside the array. So people often mark things, a public field as read-only, And I think they are safe for the whole array, but anybody could still change the data inside the array. The way to fix that is to use a collection instead, or use a method that returns the array, and to clone the array when somebody asks for it. Another issue in this same line is you have a public field, and the class is marked that it needs full trust. The security in the .NET framework only works on methods and properties. So people declare full trust on their class and expect the fields to not be accessible either. But the fields are not protected, so anybody could still read and write to this field if they want to. The last issue on this page, structs. Structs have this notion of being automatically created via the public constructor when you define a local. So if you demand full trust on one of the constructors that takes parameters, you're not secure, because every struct always has a public constructor that can always be called. So if you have a struct that contains dangerous information, you might want to consider to change it into a class instead of a struct, because classes are just more securable. Some usage rules. So usage rules are really rules that are about how you use your APIs that are in the .NET framework. So the first and the second issue, argument exception and argument null exception. When they designed the .NET Framework 1.0, they made the design mistake. And so argument exception takes two parameters. The first one is message, and the second one is the parameter name that had an issue. An argument null exception, it's just the other way around. The first argument should be the parameter name, and the second parameter should be why there was an issue. So people, of course, often call these arguments exceptions with the wrong order, because they get confused which one to call. So FxCop has a rule where they check which strings are passed and warn if you pass it the wrong way. And the fix is just swapping out the parameters. And then the last issue on this page, there's a property that's a collection in this class, and there's a getter and a setter for this property. Why is this bad to have a setter? If you have a collection, most people want to add events or some other control flow through the collection. And if somebody is allowed to completely erase the current collection and put in a different collection, all your hooked up events or other control flow just goes away. And you don't need a setter. If you have a collection, anybody could just call clear on it or add range, and so change the data inside the collection. There's no need to rip out the collection at all. So the fix here is just to remove the setter. And that's where the rules that I want to show you.
Okay. Thanks, Jeffrey. So a lot of teams here. Is this thing on? You guys hearing? Yes? No? No. Okay, well, I'll speak loud.
But will that work for the recording then?
I'm not sure. So let's just quickly do a quick demo. So a lot of teams have used FxCop 1.24, the previous version already, internally. And there's a whole bunch of new features in 1.30. And why don't we just do a very quick demo here to show you kind of what's new in 1.30. Right. Let me talk very quickly about integrating FxCop into your development process. So, as we mentioned at the beginning, FxCop, we provide two versions when you install FxCop, a GUI version, which is what we've been demoing and showing you, and a command line version, which is functionally identical, but which works against the same set of XML files that you manipulate with the GUI version, these FxCop project and report files. So typically what people will do to integrate FxCop as part of a check-in suite or into your development process is use the command line tool and kind of baseline everything. So for example, if you've got a decent sized body of code and you decide that you want to adopt FxCop, You're going to run it for the first time, and then you're going to say, oh my God, there's 2,000 messages here. There's no way we're going to stop developing features and go fix all these things right now. And so we realize that you can't stop your work and then go fix all the FxCop violations. So we provide a way to baseline things. Basically what we do in FxCop is you analyze your assembly. You say, at this point in time, here are the set of FxCop violations I have, and you exclude those violations. And then that's your baseline. That's a project, an FxCop project you can now share with people so that you effectively stop the hemorrhaging. So you can say, okay, moving forward, our process will be, I'm going to fix all the FxCop violations that occur from this point on, and then time permitting, based on the severity or what type of error it is. Is it cutting out? Mm-hmm. Oh dear, sorry. Maybe if I shut, yours will pick it up. But thank you. Okay. So, yeah, so baseline things, exclude violations, and then based upon the type of violation or the priority of, or the severity of the error, go back and fix things as time permits. So I think that that's a good strategy for most teams. If you've already shipped also code externally, if you've already shipped with .NET, or if you have applications or libraries that depend upon the framework's version 1 or version 1.1, you may not be able to fix everything. So we've got a category, which we'll show you in the tool, called breaking changes under rule categories. And unless it's a security issue, for example, you can't necessarily go and change those things because you're going to basically break everybody who's dependent upon your types in your library. So you have to be selective if you've already shipped some code about what you fix and when. But in general, if you have the luxury of starting a new code base from scratch, then absolutely go and fix the things in FxCop, fix all the violations, and then it's very easy then to keep your code FxCop clean. The other thing I should probably mention on this slide also is that these are guidelines. You know, I mean, it's a little bit different than code analysis tools where you're getting errors. We do point out some patterns that you should absolutely fix, but these are guidelines. They're not necessarily hard and fast rules. And like Jeffrey mentioned, you know, we're not executing your app. It's doing a static code analysis. And so there may be cases where you don't want to fix something that FxCop reports, and that's why we have an exclusion mechanism. There may be rules that for whatever reason don't make sense for the product that you're shipping, and it's totally acceptable to exclude things as long as you define to the rest of your team or people who are reviewing your APIs why you're excluding them. So I want to be clear about that. You know, it's guidelines, and the tool is designed to work for guidelines. It's not necessarily error, so you don't have to fix necessarily all 2,000 or whatever it is violations you may see the first time you run the tool. But definitely, like Jeffrey also said, fix design rules and focus on consistency. You know, developers don't really care so much about how we case things necessarily. What they really want from Microsoft is that we do it the same way. So that, you know, when it's 2 o'clock in the morning and I'm using 2 different namespaces from 2 of your different feature areas together, and one team cased something or did something a certain way, and another team, you know, did eventing and naming a different way, that's weird. That's a context switch a developer has to do, because I'll stop then and they'll say, why is this different? Is there a reason? And we definitely don't want people to have to do that. The beauty of the .NET framework is that it is consistent, and you see the same patterns throughout managed code. And by following these rules, I think it helps us present a consistent story to people as the number of APIs we ship gets larger. So let's see, I've got about 4 minutes left. I have a little demo here on creating custom rules that I'm going to try and do really fast. So that's the demo on how to build custom rules. And I'm going to try to very quickly now, in the remaining 10 minutes, talk about what we're doing kind of moving forward. So let's see. Whoops. So some of you may have heard this already. We announced this at TechEd, but Visual Studio Team System now incorporates FxCop. So the standalone tool will continue to be available and available free of charge. But a superset of the tool will be available as an integrated feature into Visual Studio Team System. it provides basically an integrated environment for all analysis. So rather than having to build these project XML files and having to use command line tools to invoke them as part of a check-in suite, you can have it as part of the build suite directly in Visual Studio. So for people who are Visual Studio based and teams that use Visual Studio heavily, this is a really nice feature. Analysis can be enabled as a build step, and so it's very easy to turn it on and use FxCop. The bar to adoption then is very low. And then also messages and help topics appear directly in the IDE, which is very useful. So let me just talk about some issues that people have when they use FxCop. I mentioned the first one already. FxCop is really about guidelines and not hard and fast rules. You don't necessarily have to fix every issue that you see in FxCop, although there are some that you absolutely should. As long as you follow the right process, I think it's totally acceptable to say, here's a set of things that we're just not going to fix or not going to fix for this version. Lack of integration with Visual Studio has been an issue, which is why we're building the Visual Studio team system integration with FxCop. For teams that use Visual Studio, there are a set of developers, for instance, that just won't use tools if they're not integrated in Visual Studio. And that is fixed now to some degree. But another issue is kind of maintaining these FxCop XML files across developer projects. So to have shared FxCop projects that analyze things where you have multiple people kind of contributing to the code and things you analyze, it gets a little complicated in order to manipulate the XML in order to do that. And the Visual Studio solution there, I think, is just a little bit easier. And so lastly here, I've got some rude Q&A about FxCop in general. And so inevitably, somebody will install FxCop. And the first thing they'll do is open fxcop.exe and analyze FxCop itself. And they'll say, hey, there's a couple of hundred violations in here. You know, you guys aren't practicing what you preach. What is this? This is Microsoft doing the usual thing again. But the reality is, just like any development team, these guidelines and the FxCop rules that are associated with them very often come online after we ship something. So there's a lot of code we've already shipped and code that people depend upon and APIs that people depend upon where the guidelines were just not in place by the time we do it. And usually the cost of taking a breaking change and breaking all those people is more severe, I should say, than the cost of changing it and breaking them. So there are a lot of things that we've already shipped that we can't necessarily fix. The other thing that's worth mentioning is, although FxCop is now being integrated as part of the development process for everybody developing managed code at Microsoft, it's a process that is not fully complete yet. And so there are teams, for instance, that fix every FxCop violation that comes up when they build their assemblies, and there are teams that are just starting doing that. And so if you analyze, if you have the PDC version of Longhorn, or if you have Whidbey, you may still see some FxCop violations in there. And the reason is people are in various stages of adopting it, although I would say that every team that's building managed code now at Microsoft is using FxCop. Another question that we often get is, why not ship the source code to FxCop? Frankly, we just don't think it's as valuable as shipping rules, for instance, or source code or examples on how to create your own rules. It's a much higher order bit for us, I think, to be able to help people create their own rules and get the maximum use out of the tool. And so it hasn't been a priority. It's something that we've considered in the past, but for now, it's just not something we're probably going to do. There's going to continue to be a free version of FxCop once Visual Studio Team System ships, so if teams start depending upon it, you'll still be able to get it for free. You'll still have a standalone tool. So here's some resources in your slide deck that describe where to get FxCop, how to use it, references to design guidelines. The version we've been running and showing you today is the external one that's available on gogh.net/team/FxCop. We have a weblog on blogs.msdn.com that answer questions about using FxCop, and then Jeffrey and Michael Fanning and the team usually turn around questions very quickly within 24 hours. So if you run into any issues with the tool, we're usually quite responsive. The BCL team site and Brad's weblog, if you want to understand the reasoning behind the design guidelines and associated FxCop rules, there are a couple of good places to go there. In fact, if you have questions about why we're doing something a certain way, just starting with Brad's weblog is always a safe thing to do. And then lastly, if you have questions about perf rules in FxCop, Rico's weblog at blogs.msdn.com/RicoM is a fine place to start as well.